Lesson 7.5, Task 3, Solve Radical Equations. Alright, algebraically you can solve square root equations by isolating the radical expression and then squaring both sides of the equation. Squaring the expression on both sides can introduce solutions that do not satisfy the original equation. So always remember to check each solution to see if it has an extraneous solution. Previously, you learned to rewrite radical expressions using rational exponents. This skill can also be utilized when solving radical equations. Here are two ways to write and solve the equation. Alright, so the first one you can see we're going to do it just like we've done in the previous task. So you are first going to isolate the radical, which means you have to add 1 to the other side. Alright, then I'm going to square both sides. Remember, when you have x plus 1 and you square that, you are now squaring a binomial. So that's going to become a perfect square trinomial. Make sure you don't forget that middle term. You can't just square each number. You have to square the middle term as well. All right, so here we're going to have 4x plus 9 equals the x squared plus 2x plus 1, and then subtract and set equal to 0. Then you're going to have a quadratic that you can factor, set each factor equal to 0, and solve using the zero product property. All right, very similar. You're still going to add 1 and isolate the radical, but then you're going to change the radical into a rational exponent. So remember, a square root is the same thing as something to the 1/2 power. All right, so you can still square something to the 1/2 power. 1/2 of 2 is 1, so it still gets rid of that exponent, or up here it would have got rid of the radical. All right, so from this point on, it's the same as this up here. So just remember there are two ways that you can solve that algebraically. And then it says use both algebraic and graphing calculator to check for extraneous solutions. All right. So they showed that they got two solutions, -2 or 4. And when you plug them in, -2 times 4 is -8 plus 9 is 1. So 1, the square root of 1 is 1. 1 minus 1 is 0. 0 does not equal -2. So -2 is an extraneous solution, so it's not actually a solution. And then if you plug in 4 times 4 is 16. 16 plus 9 is 25. Square root of 25 is 5. 5 minus 1 is 4. 4 equals 4, so 4 is a solution. Now, if you graph these two, you can see that 4 is where they intersect. So 4 graphically also shows that it is a solution. And if you look at -2, -2, the blue line touches, but the red line does not. Because these two lines do not intersect, that is an extraneous solution. That is not a solution. So the only real solution is 4. So what can you conclude about the solution of the equation? There is only one solution, and that's at x equals 4. Describe how solving equations written in different ways are similar and how they are different. All right, so up here, we solved these in two different ways. This one was with radicals, and this one was with rational exponents. But you can see that the operations, the inverse operations, were very much the same. So if you look down through here, those are the same. Also, when you graph it, you always have to isolate the radical first, and then graph the two different sides of the equation to find the intersection. So those are very similar to what you're going to do each time. Which way of writing and solving the equation do you prefer? I'm a math teacher, so I don't really have a preference. I would just go with what the original equation was, which is the radical equation. And I would just solve it from there. I do like to be able to check it by graphing to see if the intersection, that's a quick, easy way to check it. I probably would not rewrite it as a radical or a rational exponent, although that's no more difficult than this, but that would be my preference. All right, that is all for task 3. Lesson 7.5, task 4. All right, this time we're going to solve a cube root equation. Here are two ways to write and solve the equation. All right, the cube root of 2x plus 6 plus 4 equals 0. So very much like the square root, we have to isolate the radical first. So first thing you need to do is subtract 4 from both sides. And then the cubic power will undo a cube root. So you need to cube both sides of the equation. Remember, when you're solving an equation, you always do the same thing to both sides. Cube root undoes a cube power, so that leaves just the 2x plus 6. Negative 4 cubed is negative 64. Then you're going to subtract 6 and divide by 2 to get x equals negative 35. All right, very similar. This example is the same thing, except instead of cube root, they wrote it to the 1/3 power. Remember, 1/3 power is another way to rewrite a cube root. This is just an irrational exponent. All right, so you're still going to subtract 4. You're still going to cube both sides, and then subtract 6 and divide by 2. So both methods provide the same answer if you do the steps correctly. So x equals negative 35. Use both algebraic and a graphing calculator to check for extraneous solutions. All right, so if we plug negative 35 back into the original equation and check it, you get 2 times negative 35 is negative 70, plus 6 is negative 64. The cube root of negative 64 is negative 4. Negative 4 plus 4 is 0. So this works. That is a true solution. If you graph it, y equals negative 4 on one side, and the quantity of 2x plus 6 to the 1/3 power, or you could have wrote that as the cube root of 2x plus 6. Either way is fine. You can see that this does intersect at negative 35. So negative 35 is the solution, and we check that by graphing it. What can you conclude about the solution of this equation? There is only one solution, and it is negative 35. Describe how solving the equation is similar and how it's different. Kind of talk through that as we went. And which way of writing or solving do you prefer? All right, that is all for Task 4. Lesson 7.5, Task 5. Solve radical equations in the real world. Sierra is building a rectangular shed with her mom. The length needs to be twice the width. They need to know the area of the base of the shed in order to estimate the cost of the foundation. They also need to know the length and the width to estimate the cost of a rubber mat. The function p of a equals 6 times the square root of a divided by 2 gives the perimeter in feet of the shed based on its area a in square feet. Determine the area of the base of the shed when its perimeter is 48 feet. All right, so because it says that this is the perimeter in feet, we know that p of a can be replaced by 48. So 48 equals 6 times the square root of a over 2, and then we can solve for a. So divide, this is multiplication, so divide both sides by 6, and then square both sides to get rid of the square root, and then multiply by 2, because multiplication is the inverse of division, and you're dividing by 2 here. So a equals 128. All right, so what does the solution mean in the context of the situation? The area of the shed is 128 square feet when the perimeter is 48 feet. All right, what are the width and length of the shed? All right, at the very beginning it says the length needs to be twice the width. Okay, so the length needs to be twice the width. So what do we know about area and perimeter? Okay, so we know that area of a rectangle is length times width. We know that perimeter is 2 length plus 2 width. But now at the top, it's telling us that for this situation, the length needs to be twice the width. So instead of having length and width, okay, so the length is going to equal twice the width. All right, so now we're going to have area. Area equals twice L. So instead of L, we're going to replace that with 2W and then times W. So this is just another way to write the area for this situation. And we know that the area, we just found that the area is 128 square feet. So we're going to put 128 in for this, and then we can solve for W. So 2W times W is 2W squared. Divide by 2. W squared equals 64. And take the square root of both sides. W equals 8. So normally when this is a variable, we would do plus or minus, but we're talking about the distance of length and width on a shed. So that means it has to be a real number, a positive number. It can't be a negative number or an imaginary number. So the only true solution it can be is W equals 8. So if W equals 8, that's the width, and then the length is twice the width. So that's going to be 2 times 8, which is 16. All right, so our two answers here. The length of the shed is 16 feet, and the width of the shed is 8 feet. All right, that's all for task 5. I believe that's all for task 5. Yes, if you have any questions, please let me know.